Hey guys, so it's been a while since I've made a video, but we're going to do some subtracting fractions with unlike denominators. This is actually my kids' homework for tonight, so hopefully they'll see it before they get to turn it in tomorrow. So I have that Leo lives 4/5 miles from school and 3/10 miles from the soccer field. How much closer does she live to the soccer field than to school? You can show 4/5 minus 3/10 using a number line. They've done that right here. Use a common multiple to find the common denominator, which is what we do in class. Rewrite the fractions as needed. And they're already telling you that 4/5 can be rewritten as 8/10. I'm going to circle that and maybe put a star next to it just to remember that. Show the difference between the distance from the school, which is 8/10 miles, and the distance from the soccer field, which is 3/10 miles, on a number line. So I was talking to my kids today about how you can see how a number line is split up. Like, how do I know that this is in tenths? Well, I can count the spaces. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. That's how I know that it's split into tenths. And so they've started at 8/10 and they've taken away 1, 2, 3, 4, 5 tenths to get over here to 3/10. So it says Leo lives 5/10 or a half mile closer to the soccer field than to school. So then it says, how could you count back on a number line to find the difference between 4/5 and 5/10? Show your work. So we're going to start out at 8/10. 1, 2, 3, 4, 5, 6, 7, 8. So notice I'm just counting the tick marks to get there. So how could you go from 8/10 to 5/10? And why did I just say 8/10? Because that's what 4/5 is. Remember up here it said 4/5 is the same thing as 8/10. So I'm going from 8/10 to 5/10. And a lot of times my kids just want to say, oh, I think it's right here, but we want to make sure that we're accurate with our math. So 1, 2, 3, 4, 5. 5/10 is right here. So we're going to go 1, 2, 3. So it's 3/10 away. And then it says Salvador added up on a number line to find 4/5, which is the same thing as 8/10, minus 5/10. Use equivalent fractions for an addition equation. I'm going to underline that because that's important, to show how Salvador found the difference. Well, I'm going to write that I am remembering that 4/5 is the same thing as 8/10. And then once I remember that, then I'm going to start with this right here. That's kind of where we left off. I'm going to start with that, 5/10. Then I'm going to think, what did I have to add to get to 8/10? And I added 3/10. So that would be how I would write that. So I'm using equivalent fractions because 4/5 is written as 8/10, and an addition equation to show how he found the difference. Number 3, what is the difference between 5/6 and 1/4? Show my work. So in our class, we're always looking at these denominators and we're finding the multiples, the common multiples. So I'm going to list my multiples by skip counting. That's another way of thinking about those. So 6, 12, 18, and I could keep going. I'm going to do the same thing for 4, 4, 8, 12. I could keep going, but I'm going to stop there because I see that they both have a 12 in common. That means I'm going to rewrite 5/6 and 1/4 into something with a denominator of 12. So 5/6. I'm going to rewrite that with a denominator of 12. Well, what did I do to my 6 to turn it into 12? I multiplied it by 2. What I do to my denominator, I do to my numerator. So 5 times 2 is 10. And then I'm going to subtract, because difference, of course, means to subtract. I have 1/4. And to turn my 4 into 12, I'm going to ask myself, what do I have to multiply 4 by to turn it into 12? And I have to multiply it by 3. What I do to my denominator, I do to my numerator. 1 times 3 is 3. So now I'm going to solve. 10 minus 3 is 7. And then I keep my denominator the same. So 7/12. Our next problem says, show how you can use the visual model right here, which I see that there's 3/4, to subtract 5/8. So I know that I have 8 as my denominator over here, and I know that if I cut each of these and make 2 out of each one, that I can have an 8. So look here, if I just kind of go like this for each one, look how many I have now. 1, 2, 3, 4, 5, 6, 7, 8. I think that's pretty cool. So if I'm taking away 5 of those 8s, let's do that. 1, 2, 3, 4, 5. How many of those do I still have left? Well, just that one right there. So I have 1/8 left. This last one's a fun one. I've helped lots of kids with this one. On Saturday, Destiny spends 1/6 of the day playing in a soccer tournament. She spends 1/8 of the day volunteering with her parents at the community center. The rest of the day she spends at home. Sounds like a fun day. A day has 24 hours. What fraction of Saturday does Destiny spend at home? Show your work. All right, so I could go ahead and list out my multiples of 6 and 8, but it kind of already tells me I'm going to use 24, and I know that 6 and 8 can both turn into 24. So I'm going to ask myself, what am I going to do to 6 to turn into 24? Same thing for 8. So I know I have to multiply 6 by 4. What I do to my denominator, I do to my numerator. So 1 times 4 is 4. So she spends 4 of her 24 hours playing soccer. And then 1/8 of her day, she's volunteering with her parents at the community center. So to turn 8 into 24, we have to multiply it by 3. I'm going to do the same thing to my numerator. So 1 times 3 gives me 3. So look at that. 4 hours and 3 hours are spent doing things outside of her house. So that makes, we're going to add those, that makes 7 out of her 24 hours are spent working, like doing something. So I know that out of the 24 hours, we are going to have to subtract her whole day minus the time that she's actually spending doing something, playing soccer or working at the garden. So when we subtract 24 minus 7, we're going to get 17 out of her 24 hours are being spent at home. All right, thanks for joining.